Okay, students, so we'll move on to the next topic, that is string length mod k problems. Fine. So, in this type of question, we used to get whether the odd number of string length or else even number of string length. Okay. So, usually the divisor, the value k will be either equal to 2 or will be equal to or any other, like equal to 2 for checking whether it is odd or even. Okay, so apart from in this kind of question, like in case of odd or even, they don't mention the k value in your question. Okay, but they just mention like the string must have even number of a's or odd number of a's. Okay, then we can consider the k value as 2. Okay, so when you divide that length by 2, then the remainder, if you are getting it as 0, then we are considering it as for even exactly. If you are getting like more than 0, like 1 or any other value, okay, which is greater than 0, then we are considering it as what odd number of string length it is. Okay, so now so in this session or in this particular presentation, we are going to discuss like how to solve this kind of string length mod k problem. Okay, so what are the formula or what is the procedure involved in this? Okay, then here we can find or we can predict which one will be the start state and which one will be the final state. Okay, initially itself. Okay, so that is what one of the advantage compared to the previous one, that is divisible by k problem. Okay, then we need to identify like manually, but here, okay, using the question itself, we can identify which one will be the final state initially. Clear? So there are total 4 steps involved in this kind of string length mod k problem. We'll see that. Okay. So now let us see what is the general method to solve string length mod k problems. Okay, the general method is shown below. The step number 1, find the reminders obtained by dividing the string length by k. Okay, so as I mentioned, if we are mentioning like even number of a's and odd number of b's, okay, then the k value will be equal to 2. Okay, otherwise sometimes they used to mention, so you can observe some examples that are given over here. Okay, so if this is what the language they had mentioned in your question, like language L will be equal to W, where the length of the W mod k equal to 0. What does k stand for? Like any other value for the k apart from 2, any other value for k. Okay, so if you need to remain with 0, then this is the example for what like even or odd kind. Okay, so this is the example of what divisible by 3, divisible by 5. Okay, such kind of example. Okay, so these are the few example like how your string length mod k problem look like. Fine. So first, what we need to do, we need to identify the divisor. Okay, so what is the value of that particular divisor, and we need to find or we need to predict the reminders over there. Okay, so that we are calling it as I exactly. Okay, first we need to find the k. Okay, then we need to find the reminders over there. Okay, so that's fine. They are mentioned here. Find the remainder obtained by dividing the string length by k. The reminders obtained after dividing a k are shown below. Okay, whatever the k value will be. Okay, k minus 1, whatever the value we are getting. Okay, till that we used to get the remainder starting from the 0. If your k value is equal to 2, okay, the remainder will be what? K minus 1. Okay, means 2 minus 1, 1. Okay, means 0 to 1 exactly. Fine. So that is one. See. Okay, example 1. When the divisor is equal to 2, if k value is equal to 2, the reminders are 0, 1. If k value is equal to 3, then remainder will be 0, 1, 2. Okay, if k value is 4, 0, 1, 2, 3 exactly. Means 0 to k minus 1. So that is what the possible reminders we used to generate. And those reminders, we are naming it with what? Alphabet called as I exactly. K stand for the divisor. I stand for the possible reminders, whatever we are generating using k exactly. Clear? Okay. So next, step number 2, we got a formula, same kind of formula it is, how we were discussing string like mod k problem. Okay, like that itself, we are having one formula for string length mod k problem. That is delta of qi comma a will be equal to q open bracket I plus 1. I will be the remainder what you are dealing with. Okay, I plus 1 mod k. So whatever the remainder you are going to get for this particular function, okay, so that will be the return value for q exactly. Okay, means if you are dealing with a state called as 0, okay, if I substitute I value as 0, q naught, right? Q naught on receiving a, it will be going for what? Q of 0 plus 1 mod k exactly. Consider k value is equal to 2, then 0 plus 1 will be equal to what? 1 exactly. 1 mod 2 will be equal to 1 exactly. So this states that if q naught is receiving a, it should change its state from q naught to q1. Okay, that is what this formula mean exactly? Okay, k is the divisor, I represents the reminders like 0, 1, 2 till k minus 1 obtained after dividing by k. Okay, then so these are the components whatever we are using for the formula. Okay, apart from this, identify the start state and final state. Q naught is always the start state. Okay, by default Q naught will be the start state. Suppose the language to be accepted is, okay, in this form, W we are having, that is what this string. Okay, if the length of the W mod k, whatever the value you are generating, right, Qj, then J value whatever you are generating, then Qj is the final state. Fine. So in this question or in this example, like length of W is divided by k, and the remainder you are getting here is what, 0 exactly. Okay, for some string W, then Q naught is the final state. Okay, Q naught is the final state. So what result you are going to get over here? What is the J value you are generating over here? So that will be the final state. So for this question, 3 is what the J value. So Q3 is the final state. Here, 5 is the final, or else 5 is the result you are generating over here. Then Q5 is the final state. Okay. Then later, after finding the transition using these three formulas or these three procedure, okay, so write the DFA. The DFA can be written using the transition given in step number 2. Using this formula, we need to write the transition table. Okay, so using which we are uh, generating the DFA. Clear? Okay, so we'll move on to the problem number 1. Okay, so now, okay, fine. Question number 1. What is this? Obtain a DFA to accept strings of even number of A's. Strings of even number of A's. Simply, if you want, yes, it is possible to design a DFA, okay, for this particular question, like even number of A's, right? Okay, so you can observe. So this we already designed while discussing the first half of DFA. Okay, pattern recognition problem, like how many number of A's if you are having. Like even number of A's means like Q naught will be made as final state. Okay, the minimum requirement is what exactly, like 2 is what the minimum string we want, that means double A. Okay, so the first A and second A, Q naught will be made as final state. Okay, if I want to accept like odd number of A's, then Q1 should be made as a final state. Okay, then odd number of A's will be accepted over there. Okay, but if you want to solve this using the string length mod k problem, okay, method, then we'll see how we can deal with this. Okay, the language accepted by the DFA can be written as shown below. Okay, so same condition, we are converting it in the format of a language over here. Okay, language L is equal to a W. W stands for a string which is consisting of V1 number of A's. Okay, so now the length of W mod K. Okay, if I consider 2, okay, the length of A is, or length of W equal to 2 if I, okay, W I am writing it as double A. Okay, so the length of double A will be equal to 2 exactly. Okay, 2 mod 2 exactly. What is the remainder you are getting? 2 divided by 2, remainder will be equal to 0 exactly. Right? So this is what the language, what we can express for this particular question. Clear? So now from this, what I can identify? We can identify the K value, right? I can identify the final state. Start state, obviously, Q naught is the start state. Final state, I can identify. Okay. And along with that, I can also identify the value of I. Okay. So if K value is equal to 2, K minus 1, 0 to K minus 1. So I value will be 0, 1. I value will be 0, 1. So this states that for this question, how many states we are going to get? Only 2 states. One will be Q naught and another will be Q1 exactly. Clear? Fine. So after identifying the K and after identifying the I value and after also identifying the final state, here 0 we are getting over here. Okay. So with Q naught as the start state and Q naught as the final state. Okay. So this is what the J value we are expecting. So from the previous slide, we discussed like, so whatever the return value we are having over here, okay, for the language, so that should be considered as a final state exactly, right? So 0 we have, so 0 should be considered as a final state. That is nothing but Q naught. Okay, the transition can be obtained using the following relation. So we are using the formula, that is delta of Qi comma A will be equal to Q of I plus 1 mod K. Okay, so K value will be equal to what? 2 exactly. I value will vary, like first will be 0 and second will be 1 exactly. Okay, so now we'll draw a table. the transition table. So it consisting of two tables, two columns. So one we are calling for I, and second we are using it for the formula exactly. We'll see this. Okay, whatever the result we are generating over here. So what are the possible I values? 0 and 1 exactly, right? 0 and 1. Okay, what is the input alphabet we are dealing with? A exactly, right? So now for the I value which is equal to 0, okay, we'll observe it, delta of Qi. Qi means what? What is the I value? 0. Q naught, comma A. Okay, what is the input alphabet? A exactly. That's why I'm writing A over here. Okay, will be equal to Q of I plus 1. What is the value of I? 0 exactly. 0 plus 1, what you are getting? 1 exactly. 1 mod 2 will be equal to 1 exactly. So because of that, Q1 you are writing over here. Same thing we are substituting over here. See here, in the place of I am substituting 1. So I plus 1 means 1 plus 1 it is. So it has become 2. 2 mod 2 will be equal to 0 exactly. Okay, it states Q naught on receiving A, it will change its state from Q naught to Q1. Then Q1 on receiving A, it will also change its state from Q1 to Q naught. Okay, so based on these two transition function, okay, we are just drawing the DFA. So Q naught and Q naught, Q naught and Q1, two states we got. Okay, Q naught we need to make it as a final state because from the condition of this language, okay, we already noted that, and Q naught is the start state by default. Okay, so Q naught we are making it as final state. So Q naught on receiving A, it will change to Q1. Q1 on receiving A, it will change to Q naught exactly. So this is what the mod K problem, which is very basic kind of problem it is. Okay, so the next question we'll see a bit complicated. Okay, fine. We'll go for the second question. Okay, obtain a DFA to accept the language L, which is equal to W, which belong to 0, 1 means this particular language is consisting of the alphabet 0, 1. But W has odd parity. Okay, so don't get confused. Read the question properly. Okay, so here we are having two different alphabets. One is 0 and one is 1 exactly. Right? Okay, odd parity we have. What does this odd parity stand for? Remember, whenever we get a word called as a odd parity, okay, the string will be consisting of odd number of ones. Remember, okay, whatever may be the number of zeros, does not matter whether it is even, whether it is odd, whether it is empty, does not matter, but the string must have odd number of one. Okay, whenever we encounter odd parity, it states that, okay, we'll be having odd number of ones. Okay, we'll go for the solution. Odd parity indicates that odd number of ones should be there. The language accepted by the DFA can be written as shown below. Okay, so here we are checking for what? Okay, we are not checking for how many number of zeros we are having. Okay, we are only bothered about how many number of ones we have. Clear? Okay, we'll deal the zero later. First we will consider one. Okay, later we'll go for the zero now. Clear? Okay, so in this case the language L will be equal to what exactly? L will be equal to W, where the length of the W mod 2. See here, length of W. Inside this, like we can also write like number of ones inside W. Okay, this is also possible. Okay, but they're not writing like that. Okay, they are just mentioning like length of W mod 2. Okay, because we are checking whether it is odd or even. Okay, so 2 we are utilizing. So mod 2 should be equal to 1. Okay, means if you are having odd number of 1, then we are getting remainder as 1 exactly. If you are having even number of 1, then you are getting 0 as a reminder. Okay, so if I want to make the DFA to be accepted for a odd parity of 1, okay, then Q1 should be made as a final state. If I make it Q0 as a final state, you can observe over here. If I make Q0 as a final state, see here, it is able to accept the even number of ones. If I want to make it as acceptable for odd number of 1, then obviously I need to follow this formula, okay, so that I can define the final state over here. Okay, so 1 you are going to get over here. This states what? If you are dividing any length, okay, divided by 2. If you are having odd number of odd length, okay, then we'll be getting 1 over here. If you are having even length, you will be getting 0 over here. What you are expecting? Odd parity. So here it must be 1. Yeah, okay. The transition can be so Q0 will be the start state and the 1 you are having, so Q1 will be the final state exactly. Then transition can be obtained using the following relation. Same formula, delta of Qi comma A will be equal to Qi plus 1 mod K. Okay, so A should be replaced. Okay, A should be replaced. We'll see this, how it can be replaced in that. K value is equal to obviously 2 and I value will be as usual 0, 1. Okay, so for the values of I is like 0 and 1 we are having, delta of q0 comma 1, delta of q1 comma 1 we are having. So 0 plus 1 mod 2 will be q1. Okay, 1 plus 1 mod 2 will be equal to 0 exactly. Okay, like 2 plus 2 mod 2. Okay, like that it is. So this is what the DFA what we can design for based on this particular transition function. Okay, q0 on receiving 1, it will go for q1, q1 on receiving 1, it will go for q0 exactly. Okay, if you are having odd number of 1, then it will be accepted, otherwise it will be rejected. Now, q0 and q1, okay, the transition for value 1 is over. We need to have a transition for value 0 exactly. So, but instead q0 and q1, any number of zeros can be generated, thus having self loop at both states. Okay, so if you are providing a self loop for q0 and q1, okay, so observe it. So if you are having like 0 double 1 0, okay, 0 in the self loop, first one, second one, again 0. So it will be rejected over there. 0 triple 1 0 if you are having here 0 1 1 1, you are in the final state, again 0 you are having, you will be in final state itself. So this will be accepted. Okay, so in your question, they mentioned the input alphabets are what? 0, comma 1 exactly. Because of that, we need to provide a transition for 0 also. So better to go for a self loop. Okay. So after this, the transition table, what we can write like updated transition table, because here we are missing the alphabet 0. Okay. So like we are writing the transition table again over here, delta 0, comma 0 and 1. Q naught. Sorry, they have made it as Q naught as a final state over here. So it should be the final state. Q1 should be the final state. They made a mistake. Okay. So Q1 as a final state. Okay. So Q0 on receiving 0, it will be remaining in Q0. Q0 on receiving 1, it will be going for Q1 exactly. Same thing will be done for Q1 also. Okay. So this is what the final DFA, what we can design it for the odd parity of 1 exactly. Okay. So the next question, obtain a DFA to accept the language L is equal to W, where the length of W mod 3 should be equal to 0. Okay, multiples of 3. Remember, multiples of 3. Okay, we are facing multiples of 3. Okay, where sigma is equal to A. Okay, means whenever we are having 3 number of A's or 6 number of A's or multiple of 3, then we are able to accept it. Okay, if it is not, then it should be rejected. Clear? Okay, so from the question itself, we can identify, yes, we have the final state. The question itself, what is that? 0 we have over here, right? K value is 3, 0 we are having. So Q0 will be the start state and also the final state. I values are 0, comma 1, comma 2, comma, yes, 2, comma. That's it. Okay, 0, comma 1, comma 2. Okay, because K value is 3. K minus 1 will be the possible states. Okay, so from that we can identify Q0 will be the final state. Okay, the possible I values will be 0, comma 1, comma 2. Then K is value 3 exactly. Now we'll go for the table. Like I value 0, 1, 2. We don't have another issue like multiple alphabets we don't have. Okay, as we discussed in the previous question, we have only one alphabet, that is A. Okay, so Q0 on receiving A will be equal to, see 0 we are having, 0 plus 1, 1 exactly, 1 mod 3 will be 1 exactly. So we are writing 1. Okay, actually this should be written as 1, 2, 0, and here we need to write like Q1, Q2 and Q0 over here. Okay, this is what the conversion. But for the simplicity's sake, what we do, we are writing it here itself, direct. Yeah, okay. Q of 1, Q of 2, Q of 2, like that. Okay. So according to that, we're generating like 1, 2, 0. So we'll go for the transition diagram. So yeah, Q0, Q1, Q2 are the 3 states. So we are writing it as a triangle. Okay, it is not compulsory like it should be in the same gesture. Okay, you can write it in a straight line, no problem. Q0, Q1, Q2 exactly. So Q0 on receiving A, it will be changing its state to where? Q1 exactly. See here, Q0 on receiving A, it will be going for Q1. So we have a transition. Q1 on receiving A, it will be going for Q2. Right? Q2 on receiving A, it will be going for Q0 exactly. And which is the final state? Q0 should be made as the final state. Okay? So this is what the DFA, what we can design for this particular language. Okay? So the language can also be written as like mod 3, 0 as usual. Okay, and one more variety is number of A's. Okay, number of A's in W are divisible by 3, like multiples of 3 are divisible by 3, like that also we can do. Okay, so these are the few possibilities of mentioning this question in the language version. Okay, so later we'll go for the last variety of question. Observe it carefully. Draw a DFA to accept the language L, which is equal to W, where the length of W mod 5 should not be equal to 0. Observe it carefully. Previously, what we had, like whatever the value we have equal to, don't get confused. See here, so whatever value we are having j, okay, it also depends on the assignment operator what we are having. Okay, see here what we have, not equal to. Okay, not equal to 0. Okay, means apart from 0, whatever the states you are having, that should be made as a final state. Previously, in last 4 question or 3 question, it was equal to 0, right? Or equal to something. Fine. Okay. Then we can easily identify the final state like whatever is mentioned over here. After the equal sign, it will be called as a final state. But here, before this 0, what we are not equal to, okay, means apart from 0, rest of all should be made as a final state. Rest of all should be made as a final state. Then k value will be equal to 5. I value will be equal to 0, 1, 2, 3, 4. Total 5 different states we used to get for this question. Okay. And Q naught should not be the final state. Q naught will be the start state as usual by default. But Q naught will be the non-final state. Okay. So apart from Q naught, rest of all the states will be the final state. This is very, very important questions for us. Okay. So now the language accepted by the DFA can be written as shown below. Okay. So the same question we are repeating. So Q naught is the start state, K will be the 5, I will be equal to 0, 1, 2, 3, 4 are the remainders obtained after dividing by K. Okay, now if length of W mod 5 is equal to 0, then Q naught is the final state. Okay, if this is the case, then Q naught is the final state. But in this case, we are having like length of W mod 5 is not equal to 0. Okay, and hence except Q naught, all the final states, okay, all are final states, sorry. Okay, that is Q1, Q2, Q3, and Q4 are final states. The transition along with DFA can be obtained using the following relation. The same formula we are substituting. We have got only one input alphabet, that is A. So Q naught on receiving A, 0 plus 1. So 1 you are generating, 1 plus 1, 2. So 2 you are generating, 2 plus 1, 3. 3 plus 1, 4. Then 4 plus 1, 5. So 5 mod 5 will be 0 exactly. So this is what the gesture. Okay, it is not compulsory like you need to write like this itself. You can write it in a straight line, no issue. Okay, fine. But there will be a reverse loop from Q4. Okay, when you are entering for Q4 and if you are having any alphabet, then there will be a reverse loop from Q4 to Q0 exactly. Okay, so that is what the problems over like string length divisible by K. Okay, what is the string length here? String length will be considered over here, right? And we are dividing it by K exactly. If this is the kind of problem, it should be solved in this parity. Clear? Okay. Okay, students. So this is it for now. So we'll meet with next problem. Okay. Thank you.